His name is Jerome Friedman. He hasn't always looked like that. There were times in his life when he looked like that. A crazy physicist. And it's not a surprise, because if you look at his biography, he studied at the University of California, Berkeley, when he received his AB in physics in 1962, and then 5 years later he's got his PhD in high energy particle physics. So not an ordinary guy you'll find on the street, right? Then in 1968 he became a research analyst at Lawrence Berkeley National Lab. And in 1972, he started at Stanford University as the leader of the computational research group at the Stanford Linear Accelerator Center. They call it SLAC. Then he also visited CERN. So he's really a hardcore physicist who eventually in 1982 was appointed to become a professor of statistics at Stanford University. Here you have a very intriguing example of someone who is classically trained physicist who enters into the area of applied probability and statistics, and utilizing all that knowledge comes up with a very interesting set of ideas that revolutionized a lot of the machine learning. And in fact, in 1984, Jerry was recognized by being elected as a fellow of the American Statistical Association, and a couple of decades later, he was awarded the SIG-KDD Innovation Award, and then in 2010, he was elected as a member of the National Academy of Sciences. So this is the type of person that we are talking about, and the algorithm that I'm going to discuss moving forward is the product of his mind. So what is TreeNet? The original paper appears in 1999, and it's actually a series of papers around that time, and it's called Greedy Function Approximation, a Gradient Boosting Machine. Now, TreeNet is therefore known as Stochastic Gradient Boosting Machine. The original code introduced by Jerome Friedman in early 2000s, along with this series of papers that I'm looking at. And the first commercial implementation was offered by Salford Systems in 2004, and it later became available at Minitab as Salford was acquired by Minitab. So this is just a little bit of insight into the original history of this boosting machine that we call TreeNet. So stochastic gradient boosting can be summarized as a Jerry's way to implement that incremental learning approach when we build a small tree to learn a little bit, then assemble the residuals or the errors of that initial small tree and build a second tree trying to correct the residuals or the errors of the first tree. And we do this incremental learning in stages until hopefully we reach the point when we have learned enough. And that's where we can employ validation test or a test sample in order to identify that optimal amount of learning. So the TreeNet falls into the category of boosting methods because of this incremental paradigm. It can be viewed as a very powerful successor to AdaBoost. Jerry was not the person who introduced this area out of the blue. There were some that worked in that direction, and they came up with different ways of trying to solve this problem. AdaBoost is one such example. And today, even open source implementations are available, and most notably you may encounter it as XGBoost, which was introduced as a modification of the original Jerry's algorithm by one of his graduate students. So that's a brief history of the algorithm that we are looking at. Now, in my mind, I associate it with the true, genuine boosting in the rocket science because my initial training back in Ukraine was to be a rocket scientist. So I find it kind of fascinating and exciting. If random forest is a kind of as a power member of the bagging family, like when you have lots of multiple different takes on hits on the same subject. In a TreeNet, you have a genuinely like power learner by way of boosting. Okay, so that's the way I usually visualize these things.